Hi there, welcome to my channel mathssl. I'm speaking Saqib Latif. This is November 2020 NSC DBE Senior Certificate Exam Paper question number 10. This is also high demand question. A lot of learners ask me to solve this one. So this is the similarity question. I put this question in similarity folder. So the question says, in the diagram, a circle passes through D, B, and E. D, B, and E. Diameter ED of the circle is produced to C, and AC is a tangent to the circle at B. So, AC is a tangent to the circle at B. The question says further, M is a point on DE such that AM perpendicular to DE, AM and chord BE intersect at F. So have a look here. AM perpendicular to DE. This is the information of the sketch, and the question says, the first question, 10.1, prove giving reasons that 10.1.1 FBDM is a cyclic chord. So we need to prove that FBDM is a cyclic chord. So have a look here. Angle M2 is a 90 degree. So if we can prove this angle B2 is also 90 degree, then we can prove this is a cyclic chord because exterior angle of cyclic chord is equal to opposite interior angle, and then we can say this is a cyclic chord. Converse exterior angle of cyclic chord. So if you need to prove cyclic chord, so you three way to prove opposite angle of cyclic chord add up to 180 degree, or exterior angle of cyclic chord equal to the opposite interior angle, or angle in the same segment. They are equal, but here it's going to work exterior angle of cyclic chord is equal to opposite interior angle, which is B2. So now have a look here. This is the diameter ET. So this angle B2 is going to be a 90 degree angle in the semicircle. So the angle B2 is going to be 90 degree angle in the semicircle. Sorry, my camera was off. I realize now. So the angle B2 is going to be 90 degree angle in semicircle. Angle M2 is going to be 90 degree is given. Therefore, FBDM is a cyclic chord, converse exterior angle of cyclic chord. So therefore, angle B2 is gonna be equal to angle M2. Therefore, angle B2 gonna be equal to angle M2 exterior angle of cyclic chord. So we're gonna give the reason converse exterior angle of cyclic chord. So therefore, FBDM is a cyclic chord. 10.1.2, angle B3 is equal to angle F1. So this B3 must be equal to F1. That we need to prove. So now we need to prove angle B3 is equal to angle F1. Now, this is quite interesting question now. AC is a tangent at B, and then BE is a chord. Have a look. And this angle B3, angle between tan and chord, forming another angle in alternative segment. Have a look here. The angle D2. So gonna be equal to angle D2. Angle B3 gonna be equal to angle D2. Tan chord theorem. And then angle D2 is gonna be equal to angle F1, exterior angle of cyclic chord. So, and therefore we prove angle B3 is equal to angle F1. So angle B3 is equal to angle D2, and angle D2 is equal to angle F1. Both they are equal to same thing. That's why angle B3 is equal to angle F1. So the angle B3 is equal to angle D2, tan chord theorem. Angle F1 is equal to angle D2, exterior angle of cyclic quad. Therefore, angle B3 is equal to angle F1 because both they are equal to angle D2. So angle B3 is equal to angle F1 we proved. 10.1.3 Triangle CDB similar to triangle CBE. So now we need to prove triangle CDB similar to triangle CBE. So this yellow one similar to the pink one, the main one. Triangle CDB similar to triangle CBE, this main one. So this type of question must remember we need to prove only two angles, then we can say these triangles are similar. Angle C goes with angle C, angle D gonna be with B, angle B gonna be with E. So we need to only prove two. So let's start with C. So you can see the C is common angle. So the C gonna be a common angle in this both triangle. So we prove one. So need one more. So D goes B. So check D and B now. So I see D with B is gonna take time, but we can prove. So always go for easy option. Maybe the other angle is more easy to prove. Have a look because I can see the last one. B go with E. So that's gonna be tan chord theorem here. Have a look here. AC is a tangent. So the angle B1. This angle B1. This angle. So CBD. This angle is called angle between this angle between tan and chord. This is the chord DB, forming another angle in alternative segment. Have a look here, angle E, tan chord theorem. So this angle B1 is going to be equal to angle E. So this is a tan chord theorem. In triangle CDB and triangle CBE, angle C is equal to angle C, common angle, and angle B1 is going to be equal to angle E. That's tan chord theorem. Tan chord theorem. Tan chord theorem. This is my second angle. So D1 is third angle of triangle CDB, and CBE angle B. C angle BE is the third angle of triangle CBE, the main one. So therefore, angle D1 is going to be equal to C angle BE, third angle of triangle. 10.2, if it is further given that CD is equal to 2 units and D is equal to 6 units, calculate the length of BC and the DB. Now CD is given 2 units and the DE is given 6 units, and we need to find the BC. BC we need to find. This one we need to find. Now earlier we proved that these two triangles are similar, so I'm gonna use that similarity and then I'm gonna find the length of BC. But remember, in a similar triangle, sides are in proportion. So now we're going to write the proportion sides. So first two letters CD or DC, same thing over BC or BC is equal to last two DB or BD, same thing. So the DB is equal to or DB over the last two BE. And then the first and the last letter BC or CB, same thing, BC over first and the last CE, and we say why would the reason you might have to give similar triangles. Now, we need to prove BC. Now we need the length of BC. So now we need to take the relevant proportions. So have a look here. Uh, I'm gonna use these two, CD or BC. These two. This one I'm gonna use, and I'm gonna use this one. Why? Look here, because we need to find the BC and the CD and CE. Have a look here. CD we have 2 units, and the DE we got 6, and the whole CE is gonna be a 6 plus 2 is 8 units. So that's why I can, for me easy to use these two, because BC I need and the CE and DC I have. So now I'm gonna cross multiply. There's gonna be a BC square is equal to, it's gonna be a CD or DC or CEEC, same thing. So I say DC or CD, same thing. DC multiply EC or CE, same thing. Now CD we have 2 and EC we got 8. 8 times 2 is gonna be a 16. So the BC square is equal to 16. So therefore the BC is gonna be equal to 16 square root, because square number I switch over this and become square root. So this is my final answer. So the answer is gonna be a 4 units. So this is the last question. DB, we need to find the DB. This one we need to find DB. So this is a 90-degree triangle. I can use Pythagoras here, because DE square is gonna be equal to DB square plus BE square. Now, so we need to find the DB. So, but I'm gonna use in the meantime. Earlier we proved these two triangles are similar, so I'm gonna use their proportion sides. So remember, these two triangles are similar, so their sides are in proportion. So this time I'm gonna use these two, because the DB we need to find the DB. DB is here, so I need to use these two now. So the DB over BE is gonna be equal to BC over EC. Why? Because similar triangles. You have to give the reason. Now, so the DB over BE. So the DB we don't know, and the BE also we don't know. But we do know BC. Earlier we find the answer. BC we got 4. There is a BC 4. And the EC we have 8. So it's gonna be a 4 over 8. You simplify, it's gonna be a 1 over 2. Now you cross multiply, it's gonna be a BE is equal to 2 dB. Right. Now I can use the Pythagoras here. DE square is equal to DB square plus BE square. Pythagoras, because there is 90 degree. This 90-degree triangle. So DE square is equal to DB square plus BE square. Pythagoras we're using here, Pythagoras theorem. Give the reason Pythagoras. Now, so DE we have 6 units. Remember, DE is 6. DE is 6 units is given. So this is gonna be a 6 square is equal to dB, we don't know, dB square, BE. BE is equal to 2 dBE. So dB square and the BE, I'm going to substitute the values here, dB square plus BE. BE is equal to 2 dB. So plus 2 dB square. So this is going to be a dB square plus 4 B square. This is 36. So this is like term is going to be a 5 dB square is equal to 36. I need to find the dB square. Isolate the dB square is equal to 36 over 5. Therefore, dB is going to be equal to the square root I take over this side becomes the square number I take over this side becomes square root 36 over 5 square root. So therefore the dB is going to be equal to, I use the calculator, 6 over 5 square root, or you can say 2,68 units. So this is my final answer. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.